Bum, bum, bum. Mm-hmm. Just getting everything set up, waiting for everyone to log in. Hope we have a good crowd today. Welcome, welcome. We're gonna give everybody a few minutes to log in before we really get started. Meanwhile, just doing some messaging back and forth. Me and the other 8th grade teachers are worried about certain students that just did not turn in any work whatsoever. Mm-hmm. Well, certainly hope we get more people than just you, but this could be a cool one-on-one session. We'll see how it goes. Yay, it's Brooklyn. And we lost her. Okay. I don't see any special requests via email for problems people need help with. So we will just chew right through everything. Go ahead and kill this timer before it starts buzzing. Don't need that anymore. Okay, well, we are live. It is April 14th. We're going to do some variables on both sides to start. Here we go. Gonna keep my math practice standards ever present. I guess I can put them over here on this side. Okay, so let's start by making sense of the problem, and then we're going to persevere to solve it. Okay. So here's the equation, and we are just simply told to solve for h. Well, okay, I guess this is going to be a lot of combining like terms and then inverse operation work. So let's see what happens. First thing I would do on my own paper is write out the actual equation itself. 17 plus 4h plus 2 equals 1 minus 5h. So then I would start thinking, well, 17 and 2 are both constants. They don't have any variables attached to them, so we can go and add those together. So we'd end up with, we still have the 4h, but 17 plus 2 is 19 equals 1 minus 5h. We can't do anything with the 1 and the 5h because neither one of them is like terms. Okay. So now in an effort to get all the h's on one side, this is where I'm going to do inverse operations, and this is the part you have to know intuitively. No one's going to tell you to do it. So I'm going to add 5h to both sides. And the reason for that, I'm going to abstract, I'm going to make reasonable, blah, blah, blah. I'm going to reason abstractly. And the abstract reasoning that I'm going to be employing right now is this: that anything plus its opposite is equal to 0. And then in a minute, another one I'm going to use is that anything divided by itself is equal to 1. Now that lesson serves me very well here. Another thing I'm going to be doing, I'm going to go ahead and subtract 19 from both sides because that's the opposite of adding 19. So here's what ends up happening when done correctly. So negative 5h plus 5h, that makes 0. And 19 minus 19 makes 0. So what we're left over with, 4h plus 5h is 9h. I had to add 5h to both sides because it's an equation. We have to keep things balanced. Then, if I'm subtracting 19 from both sides, 1 minus 19 is going to be negative 18. But 19 minus 19 is 0. Without fail, I'm always yawning in my second string. So 9h equals negative 18. So in my next round of inverse operations is that abstract rule I was talking about, anything divided by itself is equal to 1. So if I were to divide this side by 9, I have to divide this side by 9 because it's an equation, keep things balanced. But 9 divided by 9 is 1. So what you end up with is just 1h. And negative 18 divided by 9 is negative 2. So solving for h in this system means that h is equal to negative 2 always. So let's see, what else did we do there? We definitely attended to precision. We were very careful. We reasoned abstractly. We showed the model for our mathematics, and I believe that we did construct an argument to prove what we thought was correct. Not bad for a problem. Okay. Welcome, welcome, those of you that are just joining. I'm checking my email constantly to see if someone has sent in a picture of one they would like to do. But that was a quick demo of solving an equation where variables are on both sides. In this case, it's just one variable. That's fine. Let's try something a little different. So this is similar in that we'll be doing a lot of the same mechanics. However, it is different in that this one has decimals, but that should not be a deterring factor, really. So rewrite the equation. That'd be 4a plus 5 equals 2 plus 3.25a. All right. So the first thing I'd like to do is combine like terms, but as I'm looking at this, I'm noticing that 4a plus 5, 2 plus, yeah, there are no like terms to be combined here like there were on the last problem. So in this case, we're going to go ahead and start with our inverse operations, and these are things you have to think of intuitively. No one's going to tell you to do them. So since I've got 4a here and 3.25 here, I want to stay positive if at all possible. So I'm going to go ahead and subtract the smaller number. So this will be, I'm going to take away 3.25a from both sides. I will also, because I want to get the constants over on the one side, I'm going to go ahead and take away 5 from both sides. That way, all the constants, those are the numbers without coefficients or letters, are going to be all together. So what you end up with, 4 minus 3.25, that's the same as 4.00. A minus 3.25a. So we're going to end up with 0.75a. It's a 5, I promise. So back to our abstract rules that we were talking about before. We're going to reason abstractly right here. So 5 minus 5 is 0. 3.25a minus 3.25a, that's 0. So our 7500ths a, 0.75a is going to be equal to 2 minus 5, which is -3. We got a couple ways we can do this now. We could just, strictly speaking, the next step really to do is to divide both sides by 0.75. So technically speaking, that is the next step. There are a couple other ways to do this. If you just hate decimals, if you just despise decimals, I'll show you that way in a minute. So 7/500 divided by 7/500 is just 1. So we'd end up with a, just 1a, which is what we were hoping for, equals -3 divided by 7/500. So that comes out to be, I think it's -2. No, it's not. That'd be -1.5. Back that up. 75 goes into 3 4 times. I know that because 2 7/500 makes $1.50. So the answer is going to be -4. Now, that being said, if you are just unholy upset when you see decimals come out, I think I can back this up and show you. So it's going to be -4. However, I think I can get us there a little bit of a different way if this is more appealing to you. Let me just go ahead and grab all this. Get rid of that. Okay, so let's rewind back to where we had 0.75a is equal to -3. And just because I've got an intuition, what happens if you multiply both of these by 4? This should take care of your decimal problem. Because if you multiply them both by 4, 2 of these makes 3, so this would be equal to 6 equals -12. Back that. 75. No, back that up. Boom, boom, boom. So what I'm doing now, just to highlight that, I'm just attending to precision. I'm trying to make sure my math is absolutely correct. Back that up. Okay. 7 times 4. Every 2 of these makes 1.5. So this would be 3. That's what I meant to say, not 6. And this would be -12. So that way we just clear out the decimals. I found a factor that if I multiplied it by, my product would be a whole number. So now you can just divide both sides by 3, and you still end up at -4. So there it is. It's the same skill. You have variables on both sides, but there are decimals and sometimes fractions involved, but the skill doesn't change. It just gets a little more complex. We have to attend to precision a little bit more carefully. That's all. This next one I'm going to put on the board, and then I'm going to go check something real quick in my house, and then we'll both come back and solve it. I apologize about that. My 5-year-old was very excited about something, but I couldn't tell if the excitement was a problem excitement or a fun excitement. Okay. Oh, math is fun. All right, let's check this one out. So the first thing I would do is I would rewrite my problem on my own paper, which I'm hoping everyone at home is doing. So -11f equals 7 times, that's parentheses minus 1 minus 2f, and parentheses plus 5. Let's see if I left anything out. -11f equals 7 parentheses 1 minus 2f and parentheses plus 5. Nope, we're good. Okay. So all we've done so far is just make sense of the problem, and now we have to persevere in solving it. Let's say, yeah, I think the first thing I'm seeing here is that I'm gonna have to do this distributive property, where I have to multiply the 7 by both terms on the inside. It's a binomial, there's two things. So this -11f has not been affected. 7 times 1 is 7. 7 times a -2f would be -14f. And then we still have this plus 5 on the end. Our next step would be to combine like terms. So this 7 and this 5 are constant. They don't have any variables connected to them whatsoever. So we can go ahead and combine them. We'll leave the -11f alone for now. 7 plus 5 is 12. And we still have this -14f. So we're finally going to use some inverse operations. So let's just get all the f's over on one side. And we can make sure that it'll be positive if we take this one and put it over there. So let's just go ahead and add 14f to both sides. So what we're doing here, we are reasoning abstractly because I know and you know that anything plus itself makes 0. So this, quote unquote, cancels itself out, as the famous math saying goes. Now -11f plus 14f, -11 plus 14. So we end up with 3f equals 12. Okay, So our next inverse operation, we'll just divide both sides by 3. Now the reason we're doing that is because 3 divided by 3 is 1, which is what we wanted. So you'd end up with 1f equals 12 divided by 3, which is 4. So we attended to precision. I believe that the structure we're using of this, I call it ladder math, where I keep writing things down underneath where they were before. I do one step at a time. I'm making these little marks to keep myself organized. I'm basically constructing my argument that this is why everything is true. Yeah. Okay. So that's how that goes. After this one, I'm hoping you guys will actually chime in and give me one that you would like to see done. I haven't received any emails from anyone saying, hey, can you solve one like this? And this morning, my earlier stream, that was a great, like I did 4 or 5 or maybe even half a dozen problems that people had actually sent me saying, hey, I need help on this. And that would make these streams really more potent if we were actually helping each other out. Okay, so I need everyone to write this down on paper and see what you get. Now, this one is a little more technical. It's the exact same skill, except they just put in decimals. Start working on this. I need to go AFK just for 1 second. And we're back. Here we go. All right, so the first thing I'm going to do here is look for like terms that I can combine, and unfortunately, I don't see any. I can't combine these because one has a C and one doesn't, and I can't combine these because one has a C and one doesn't. So the first thing I'm going to end up doing is this distributive property. I've got to multiply this 2/10 by both terms in this binomial. So what do we get? 2/10 times 10. Anything times 10 is going to move that decimal over one place. So that would just be 2. -5 times 2/10. Well, 2 times 5 is 10. I have to move the decimal place over 1 time. So this is just going to be -1c. Because -5 times 2/10 is just, -5 times 2/10 is -1. Yeah. And this I haven't done anything with, so it's just 5c minus 16. So this is where your intuition has to kick in. And we've got to start doing some inverse operations. So, and at this point, what I'm really doing is I am remembering what I've done in the past, like on the previous problems. So this is my repeated reasoning. What worked before should work now, while I'm being very precise with my mathematics. So inverse math, okay. Let's say, just to keep things positive, I add 1c to both sides. And then because all the c's are going to end up on the right side, I need to get all my constants on the left side. So I'm just going to go ahead and do the opposite of this. Let's just add 16 to both sides. So our abstract reasoning kicks in here, where I know that if I add two things that are opposites of each other, they'll cancel each other out because they make a 0. So let's see. So negative 1c adding 1c makes a 0, and negative 16 plus 16 makes a 0. So what we end up with, 2 plus 16 is 18. Negative 1c and 1c make 0. So 18 equals 6c, I'm sorry, 5c plus 1c makes 6c. So then our next bit of intuition comes in, where we'll divide both sides by 6. Six divided by 6 is equal to 1. So that's just going to be 1c. And that's the whole reason we did that, because we want c equals stuff. So 18 divided by 6 is 3. So therefore, c is equal to 3. Blum, blum, blum. Still looking for individuals posting. Not yet. Nothing in chat, nothing in email. Okay. Well, then I will pick the next problem. That's fine. This is more fun. Those last 3 or 4 problems have been very much just like kind of rote procedure, follow the steps, blah, blah, blah. This is more intuitive, just fun to think about. Okay. So when we ask ourselves how many solutions a problem has, we're asking about basically its graph. So if there are no solutions, that means the system would never cross and have a point of intersection. One solution means the system crosses at one point, like 2 lines across at a single spot. And then infinite solutions is when the 2 lines are on top of each other. So the way we're going to prove this, let me move down just a little bit. I wish my annotations would stick on the screen, but oh well. Okay, so here's how we prove which integers are which. Okay, no solutions is when you end up with an equation that ends up something like 5 equals 7. That's just not true. Exactly one solution is where you'll end up with something like x equals 4. Infinite many solutions is when you get something like 9 equals 9, something that's always true, something like that. So those are the 3 different ways we model in the equation that we get those answers. Okay, so let's talk mechanics. First thing I'm going to do is rewrite my equation. So that's 13 in parentheses, y plus 3 in parentheses. I better scoot this over or I'm going to run out of room because of our pictures. Equals 13y plus 39. me check that. 13, y plus 3, 13y. Yeah, okay. So combining like terms, I don't see anything that I can combine just yet. So what I am going to do is do the distributed property of 13 times both terms of this binomial. So 13 times y would be 13y. 13 times 3, so that'd be adding 39, equals 13y plus 39. Uh-oh, look at that. I think we're done working. So 13y plus 39 equals 13y plus 39. So I'm hoping you immediately notice that looks like one of these. Kind of reminds me of this guy down here. We've got the exact same thing on both sides, which means I like this one. Says my heart stickies. Yep, that would be an infinite solution because both sides are the exact same. Before we go on to the next one, let's see. So we made sense of the problem. We didn't really do much abstract reasoning. We constructed a viable argument, that's for sure. Wow, those are horrible straight lines. Okay, let me try that again. We made sense of the problem. We constructed a viable argument. We modeled a little bit, not all that much though. We tended to precision, being very exact with our thinking. Anyway, I might be overstating myself on this problem. We did some thinking, but not all the steps, I don't think. However, I know for a fact that I was using repeated reasoning because I was thinking back to problems we recently did. Like, yeah, that's exactly what we did before. And guess what? It works out both times. So that's how you tell the difference between having one solution, infinite solutions, or in this case, or exactly one. But in this case, it was infinite. Sweet. Let's see. What else would be fun to do? This is the number of solutions challenge. This means they should be harder. That'd be fun. Which one of the following equations have exactly one solution? Aha. Okay. Which of the following equations has exactly one solution? Okay, chat. Let's get active. I want you to chime off in the chat with which one or ones you think are appropriate. Keep in mind, it does show this where it says choose all answers that apply. We want exactly one solution. Now, to reiterate what I just said, that means that at the end of this, you should have x equals number. And it can be any number, negative, positive, decimal, anything. As long as it ends up with x equals something, then you got a one solution system. So I'm going to give you just a minute of a head start, and then I'll start going through these one by one, and we'll see if we all agree or if we disagree. Okay, so let's see what can be done with these. 12x. So if I were to subtract 12x from both sides, I'd end up with 1x here. I could add 12 to both sides, it'd be 24. So yeah, this ends up with one answer. With this one, if I were to take away 12x from both sides, I'd end up with 1x again. And I could take away 12 from both sides. So x equals 0. That's still an answer. X equals 0. In this case, if I were to add 13x onto both sides, I would get 26x. And then I could take away 13 from both sides and have negative 1. Yeah, even though the answer would be like negative 1 over 26, that's still one answer. So this one, if I added 13x onto both sides, I'd get 26x. I could add 13 onto both sides, I'd get 25. And again, even though we do weird division, you end up with 25 over 26. That's still equal to x. That's still one answer. So far, I like all of them, which is weirding me out. It's making me think I must have messed something up. But as far as I can tell, okay, well, I'm making my case. I'm stating my argument. So let's see what happens. Oh, and I was right. They are all cheeky. So what I just had to do before I hit that button, because I was really weirding myself out, and you guys might get the same sort of an itch when you see this happen. So I made sense of the problem. I reasoned abstractly because I had said that, that having one answer is x equals any number. I modeled my math using the appropriate strategies. I was really precise. I was using all the reasoning that I'd used before, and I guess you could call the equation structure. But at the end, the biggest one for me was this one. I had to construct a viable argument. I had to actually convince myself that I was right before I would hit the button. Cool. Okay. Move that off screen. So this next one is going to come to us from an email request, which is what I love. I love to do ones you guys send to me. It's much more meaningful to everybody involved. Actually, hang on. Let me make this a little bigger. Okay, check this out. Okay. So what we're being asked here is find out how many solutions are in this. And just to reiterate how this works, no solutions means you'll have something like 43 equals anything else. That's no solutions. Exactly one is what you'll end up with. In this case, y equals number. It doesn't matter what the number is, positive, negative, decimal, it does not matter. As long as you get one number or value, then that's one solution. And as far as infinite, you'll end up with something to the effect of like, I don't know, 8y equals 8y. anytime the left side of the equation and the right side of the equation are just twins, that's when you have infinite number of solutions, because it doesn't matter what y is, they will always be the same value. So I guess that being said, let me move you guys over here. That being said, let's write this question out again, this equation that is for text. So negative 15y plus 7 plus 17y equals 2y plus 70. See if I missed anything in that. I don't think I missed anything. Negative 15y plus 7 plus 17. Oh, careful, Mark. Careful. That's a 17y. Okay, let me say it again. Negative 15y plus 7 plus 17y equals 2y plus 70. Oh, that was close. I got to attend to precision. Be very careful. Okay. I've already reasoned abstractly because I know exactly what each one of these answers means. That means I've made sense of the problem. I need to start doing all these other things though. Okay, so let's start working. So combining like terms. Okay, well negative 15y and 17y are like terms. They can be combined. So negative 15 plus 17 is 2. So I'd end up with 2y. I still have that plus 7 equals 2y plus 70. Uh-oh. 2y plus 7 equals 2y plus 70. Ugh. I'm already thinking it's going to be a no answer. We can help ourselves out a little bit. What if we just took away... What if we took away 2y from both sides? So that means that this cancels out and this cancels out. Not good. So what we end up with is 7 equals 70. Yuck. Yeah, that is a no solution situation because they will never be the same thing. So I would choose A for that one. Great question. Here we go. Now they're just rolling in. Sweet. So this is one of our challenge questions. Where it's asking us to figure out which of the following have infinite. Okay. So let's do some abstract reasoning here real quick. So the infinite many solutions. What is? Come on, mouse. Why are you doing that? Okay, infinite number of solutions. That means what we're looking for is an answer that ends up with something like, I don't know, 2x equals 2x. Something to that nature where they're the exact same. The reason it's infinite is that no matter what x is, if x is 7, 8, 24, negative 3,900, whatever, both sides are going to balance. Thus, there are an infinite number of x answers for this equation. So it's our job to try and find them. So let's do that. Okay. So x minus 37 equals x minus 37. I don't even need to do any math. I already like this one. That's not what I wanted. They're the exact same on both sides already. So that one's done. 73x minus 37 equals 73x minus 37. They look the same to me. Okay. 37x minus 37 equals 37x minus 37. 37x minus 37 equals 37x minus 37. Yep, it looks right. Is this going to be another one of those where they're all right? Let's see. 74x minus 37 equals 74x minus 37. Are they the exact same? Yeah, I think this is another one of those where they're going to try and trick you. Now, they said select all that apply, and it looks like they're all fine. Usually the way they try to trick you is they put in one with a plus sign or one with a 37 instead of a 73 or whatever, but they all look to be the exact same mirror images of each other. So yeah, they all look to be good on this one. Good question. I'm not surprised that one would cause someone to take pause. I mean, I know I did the first time I saw them. I got another request. Let's look at this one. I'm not sure how long it'll take to solve this one, but it looks like it might be our last one of the day. We'll see. We'll see. Okay. So how many solutions does the following equation have? And just to hammer the message home, having no solutions means you'll have something like 3z equal, 3 equals 10, which can never be true. Or maybe for exactly one solution, you'll end up with z equals 12. And for infinite solutions, you'll end up with something like 6z equals 6z, something like that. Anything where it's the exact same on both sides. Sorry, I dropped something. So those are the three things that we are looking for. Just keep track of what we're doing. Those are my abstract, just make it up reasons or explanations for what these three things. So no solutions, exactly one, or infinite. And their definitions. We've made sense of the problem and we're going to persevere in solving it. Let's see. I'm basing all this on previous experience. So like my previous reasoning is still valid, still works. So let's go ahead and crunch the numbers here. So 3z plus 9 plus 14z equals 4z plus 5. First thing, I gotta make sure I typed that out right. The last one, I messed it up. 3z plus 9 plus 14z equals 4z plus 5. Okay, well, hurdle 1 crossed. I wrote down the question correctly. So now let's combine some like terms because 3z and 14z both share the same variable, so they can be added together. So that'd be 17z plus 9 equals 4z plus 5. Okay, so now we can do some inverse operations. Where if I were just to take away 4z from both sides, and for the record, as soon as we hit this point, I'm pretty sure I already know what the answer is, but just in case, we're going to keep working. But we can go ahead and take away 4z from both sides. And while we're at it, let's just go ahead and take away 9 from both sides. So we'll have all the constants on one side and all the variables on the other. So that means that that cancels out and that cancels out. What I end up with is 13z on the left and 5 minus 9 being negative 4 on the right. And at this point, I'm sure I know what's going to happen. So what we can do here is we can divide both sides by 13. And what we end up with is this really kind of gross looking z equals negative 4/13, which is fine. Nothing wrong with it. Nothing. I don't have anything against the negative 4/13 side of the universe, except most of the time we like things to be whole numbers, integers. We want, that's a very comfy feeling for us. But in this case, the fact that it came out to z equals anything is a tip that it's exactly one solution. If it comes out to z equals blah, one value, whether it's a decimal, fraction, positive, negative, whatever, that means that there is one solution to this system. Okay, well, it's been a fun hour. I'm gonna check and see if there's any last minute questions. I don't see any. Um, if you're watching this on the replay, I hope you made your bed today and got some work in. Make sure you check Google Classroom. I actually need to post something on Google Classroom because I made the announcement on Classroom what your assignments are for the week, but I didn't actually post it in the Classroom section, which might have made things ambiguous. I will fix that. You have 9 con things assigned, but only 2 are for grades. 7 are just for practice, practice, practice. The 2 quizzes are your grades this week. So if you have any other questions, feel free to contact me. Check out the YouTube for, oh yeah, also Midsummer Night's Dream. Make sure you're reading it for Miss Elliott. I should finish Act 1, Scene 1 today after this stream. It's actually a pretty fun story so far. And especially you ladies, you should be totally mad when you're reading it as to how the men just treat women like objects. It is pretty rough if you're looking for it. So take care, and I will see you guys next time.